Okay, let's look at our test review for trigonometric equations and identities. In this first section, we've got some trig equations. We're asked to solve for x between 0 and 2 pi. In our first example, you can see that we've got a quadratic, which indicates that we're going to need to factor. And I've got two terms there. They both have a sign. So I'm going to factor out sine x. And inside the parentheses, then I would have left sine x plus 1 equal to 0. And so now that I've got it factored, I'm going to set each factor equal to 0. If sine x is equal to 0, then that means that x is equal to 0 and pi. Those are the angles where the sine is 0. And over here for my other factor, sine x would be equal to -1, and that happens when x is equal to 3 pi over 2. Alright, let's look at question number 2. In this question, we need to get the trig function by itself, the cosecant. So I'm going to start out by subtracting 8 from both sides. And I get 2 cosecant x is equal to -4. 4 minus 8 would be -4. Then we're going to divide by 2. And cosecant x is equal to -2. Now cosecant is not on our unit circle, but it is the reciprocal of sine, which is on the unit circle. And so if cosecant is equal to -2, then sine x is going to be equal to -1 over 2. It's equal to the reciprocal of 2. I'm sorry, of -2. And sine is equal to -1/2 whenever x is equal to, let's see, sine is negative in quadrants 3 and 4, and it's 1/2 at the pi over 6 angle. So that's 7 pi over 6 and 11 pi over 6. Alright, in the next section, on number 3, I think we had a mistake on the review. It said to find sine 75 using a double angle identity, but that doesn't work. So we're going to use a sum and difference identity instead for sine 75. And I'm going to rewrite 75 as 30 plus 45. Now there's a lot of different angles you could have chosen, different things that will work, but I'm just going to choose these. And I'm going to use my sum identity for sine. This is going to be equal to sine of 30 times cosine of 45 plus cosine of 30 times sine of 45. And then I'm going to substitute in unit circle values for those angles. The sine of 30 is 1/2. Cosine of 45 is square root of 2 over 2. Plus the cosine of 30 is square root of 3 over 2. And sine of 45 square root of 2 over 2. And if I multiply that out, I get square root of 2 over 4 plus the square root of 6 over 4. And since those have a common denominator, I'm going to go ahead and combine them together and make my answer square root of 2 plus the square root of 6 over 4. Now we're going to find sine of 75 using a half angle identity. And so 75 would be the same as 150 divided by 2. If I'm going to use a half angle identity, I want to find an angle that I can cut in half to get the angle that I'm interested in. Now if I look at my identity, my half angle identity for sine, I see that I have a choice between positive or negative. And so I'm going to think about the original angle, that's 75 degrees. I know that angle's in quadrant 1, and if I'm in quadrant 1, then my sine value should be positive. I'm going to write a positive sign there just to show that we thought about that our answer is going to be positive. And then I'm going to use the identity. It's going to be the square root of 1 minus cosine of 150 degrees over 2. And that's going to be equal to 1 minus the cosine of 150 is negative square root of 3 over 2 and that's all over 2. And I'm going to get a common denominator there in my numerator and make that, let's see, the common denominator, of course, would be 2. So it's going to be 2 over 2 plus the square root of 3 over 2. I just changed that 1 to 2 over 2. And this is all over 2. And so a final answer here is 2 plus the square root of 3 over 4. I can multiply, if I'm dividing by 2, I can multiply by the reciprocal 1/2, and that puts my two denominators of 2 together to give me 4. All right, let's move on to the next section. Here I've got a sine theta is -4/5, and theta terminates in quadrant 4. Theta is a quadrant 4 angle. So I'm going to draw a reference triangle in quadrant 4. This is theta. And they told us that sine is -4/5. Sine is y over r. So that means that the -4 goes over here. And the radius, the hypotenuse, would be 5. And so this is a 3, 4, 5 right triangle, which means my x side is going to be 3. So now let's see if we can use this triangle to evaluate these two trig functions. Cosine of theta over 2. Well, first thing I'm going to do is write down my half angle identity for cosine. That is a half angle there, and that's going to be equal to the square root of 1 plus cosine theta over 2. But we still have that plus or minus in front, and we need to make a choice here. So let's think about this. I've got an angle in quadrant 4. If I divide that angle by 2, which is what we're doing in number 5, it's the angle theta divided by 2. If I have an angle in quadrant 4, that means that theta has to be somewhere between 270 and 360 degrees. So if I divide theta by 2, I've got to divide everything by 2. And that means that theta over 2 is going to be between 135 and 180, which puts us in quadrant 2. And if we're in quadrant 2, cosine, which is the x-coordinate, is negative. And so I know here that my answer is going to have to be negative. And now I'm going to substitute in the value from our triangle. This is going to be equal to negative square root of 1 plus the cosine of theta. And if I look back at my triangle, I can see that cosine is 3 over 5, and then that's all over 2. I'm going to get a common denominator in my numerator, which would be 5 over 5 plus 3 over 5 all over 2, which is going to be equal to 8 over 5 over 2. And if I multiply by the reciprocal of 2, I get the square root of 8 over 10, or finally square root of 4 over 5. Next one, sine 2 theta. I'm going to start by writing down the identity. This is a double angle, and sine of a double angle is equal to 2 sine theta times cosine theta. And now I'm just going to plug in those values from my triangle. 2 times sine theta in my triangle is negative 4 over 5, and cosine theta is 3 over 5. I'm going to multiply all those together. I get negative 2 times 4 is 8 times 3 is 24 over 5 times 5, which is 25. All right, let's move on to the next section. Here we're asked to use sum and difference identities to find these values. When you're using sum and difference identities, you're just looking for two angles that you can add or subtract so that you get the angle that we're interested in. Sine of 105. I think I'm going to use a difference and say that 105 is equal to 150 minus 45 degrees. You could have picked other angles. If you chose other angles that add to 105 or even other angles that subtract to 105, you're still going to end up with the same final answer as I do. This is going to be equal to sine of 150 times cosine of 45 minus cosine of 150 degrees times sine of 45 degrees. And now I'm going to plug in my unit circle values. Sine of 150 is equal to 1/2. Cosine of 45 is square root of 2 over 2. Minus cosine of 150 is negative square root of 3 over 2. Negative because 150 is over there in quadrant 2. And sine of 45 is, of course, square root of 2 over 2. If I multiply this out, I get square root of 2 over 4. And then I have minus times a negative, so that's going to become plus square root of 6 over 4. And for my final answer, since I've got a common denominator, let's go ahead and combine those into one fraction. Square root of 2 plus the square root of 6 over 4. All right, cosine 255. I'm going to pick two angles that add to give me 255. Let's do cosine of 210 plus 45. All right, now the cosine sum and difference identities are a little bit different than the identities for sine. This is going to be equal to cosine of 210 degrees times cosine of 45 degrees minus sine of 210 degrees times sine of 45 degrees. And now I'm going to substitute in my unit circle values. Cosine of 210, that's going to be negative square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Minus sine of 210 is negative 1/2. And sine of 45, square root of 2 over 2. So now if I multiply this out, I get negative square root of 6 over 4. And then I have minus times a negative, so that's going to become plus square root of 2 over 4. And common denominator, let's go ahead and combine those together. Negative square root of 6 plus the square root of 2 over 4. All right, in our next two problems, again, we're working with some given values, and we're going to use reference triangles. So I've got sine of alpha, which is 4/5, and alpha terminates in quadrant 2. So let's go ahead, quadrant 2. Here we go. I'm going to draw a quadrant 2 reference angle. So this is alpha. We're told that sine is 4 over 5. So that's y over r. And so my x side, of course, would be 3. And since we're in quadrant 2, that's going to be a negative 3. Now I have another angle here, beta, and beta terminates in quadrant 3. So I'm going to draw a reference triangle in quadrant 3. This is beta. And for this angle, we know that cosine is negative 12 over 13. So x over r, negative 12 over 13. And 5, 12, 13 is a Pythagorean triple. So this side, my y side, is going to be 5. And since we're in quadrant 3, it's going to be a negative 5. So now let's see. We're being asked to find tangent of alpha minus beta. So I need to find that difference identity for tangent. I'm just going to write the identity first. Tangent of alpha minus tangent of beta over 1 plus tangent alpha times there we go, times tangent beta. And now let's substitute in values from our triangles. This is going to be equal to tangent of alpha. Now if I look at alpha, tangent of any angle, any reference angle is going to be y over x. And so for alpha, my y over x is 4 over negative 3 minus tangent of beta. If I look at beta and do y over x, I get negative 5 over negative 12. And since they're both negative, I'm just going to write that down as positive. Tangent's positive in the third quadrant. Over 1 plus tangent alpha, which we already figured out was negative 4/3, times tangent beta, which is 5/12. Okay, so now we need to get a common denominator in the numerator and in the denominator. And it looks like with those two denominators of 3 and 12, 12 would be the least common denominator. But if you look at your the overall denominator, if you notice down here, these two fractions, negative 4/3 and 5/12, I'm going to have to multiply those together. And when I do that, I'm going to get 1 minus 20 over 36. Since my denominator in the denominator is going to be 36, I think I'm going to do the same thing in the numerator as well. So I'm going to change 4/3 to have a denominator of 36. So I'm multiplying by 12. So this is going to be negative 48 over 36 minus, and then I'm going to change 5/12 to have a denominator of 36. So I'm multiplying by 3, which would make my numerator 15. And now let's see where I'm going to go on my screen. I think I'll drop down here. So in my numerator, I have negative, let's see, 48 and 15, negative 63 over 36. And then in the denominator, now I still have that 1, but that 1 can become, let me just mark it out here. We're going to make the 1 36 over 36. And so 36 minus 20 would be 16 over 36. Now I've got two fractions. Whoa, and I can multiply by the reciprocal. Negative 63 over 36 times 36 over 16. Notice here my 36's cancel out. That's why I wanted to get the same denominator in both places, because I knew it would cancel out here at the end. And finally, we get an answer of negative 63 over 16. All right, let's look at sine alpha plus beta. This one's going to be a little bit more straightforward than the tangent. I'm going to do the sum identity first. Sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And then I'm just going to substitute in the values from our triangles. If I look at alpha, sine is y over r, and so that would be 4 over 5. Cosine of beta, cosine is x over r, and so that would be negative 12 over 13, plus cosine of alpha. Again, cosine is x over r, and for alpha, that's negative 3 over 5. And sine of beta, y over r, for beta would be negative 5 over 13. For my first product, I get negative 48 over 65. And then I have plus, and negative times the negative would be a positive 15 over 65. And negative 48 plus 15 would be negative 33 over 65. And that would be our final answer. I'm going to stop here and pick up with the rest of the review in video 2.